Happy Mercedesing. In this video I'm going to be speaking about the electronic part of the Ke-Jetronic system, as I promised. If any of my videos helped you repair your car, then please hit the button thanks. If you, you, want to be the first one to watch my videos as they're fully uploaded, then become a supporter of the channel. And if you want to watch the service manuals, then become a donor. Thanks. And if you would be kind, please, to support my Patreon, then here is the link to that site, and see you there also. This is going to be the longest video I have ever made, but stay with me, because in this video I'm going to be speaking about the sensors, the components on the system, about their symptoms, and of course about their malfunctions, about the malfunctions of the sensors, of the relays. Everything I could think of I put in this video. But before I start this video, I would like to give a special greeting to a special person. His name is Zaid. So please, my dears, give him a huge kiss from Serbia. Well, hear you soon, my man. As soon as you get the Lambda probe, your 560 SEL is gonna be purring like a kitten. And now let's go to the video. The electronic part of the system consists of the OVP, or the Overvoltage Protection Relay, which is the power supply for our computer, for the ECU. It consists of the fuel pump relay, of the ECU itself. Further, it consists of the cold start valve, because it has its electronic part of the system. It's coil here, of the EHA, of the idle control valve, and it consists of the sensors. So let's count them. The most important one, I would say, it's this one. That's the crankshaft position sensor. Without this sensor, you cannot even start the car. Then we have the micro switch, the sensor potentiometer, the throttle position sensor, air intake temperature sensor, coolant temperature sensor. It consists of the Lambda probe, which is in some models screwed in the exhaust manifold, and on some models into the exhaust pipe. On my vehicle, it's located in the exhaust pipe under the vehicle. It consists of the whole speed sensor. I will show you that one. That one is in the instrument cluster. One more important sensor is the H11, the X11, where you can measure your air-to-fuel mixture on these ports 2 and 3, and on the later versions, starting from 89, you can connect the ports 4 and 6, where you can measure the RPM. If you have the multimeter with RPM function. On this model, it's not possible. I will just show you which one goes where goes to number 4 and the negative to number 6. And here you have number 7, 8, and 9. These 3 ports are predicted for the oscilloscope if you have it, so you can then attach the positive goes to number 7 and the negative goes to number 9, and there you can watch your timing if it is in the right place, because you can take a readout in milliseconds. That one measures the signal from the TDC sensor. But the most important thing here for us is port number 3, where we set the mixture. Here on the CO screw. Number 1 here is the TD signal, the RPM signal. Number 2 is the negative. Here this is for the injection, etc. These here are for the ignition coil, and so on and so on. Considering the ECU almost never fails. The rare cases are if they fail. The only thing you can do in order to destroy the ECU is to take your multimeter and to remove its plug here and to start measuring resistance, and you have the ignition on. That's the way how you can destroy the ECU. Otherwise, not like that. The same goes for the fuel pump relay. The fuel pump relay, this thing almost never fails. I've been speaking about the OVP. The OVP is the power supply for the ECU, for the ECU ABS, if you have ABS on your car, and for the idle control valve. That's its purpose. And of course, if out of who knows which reason we get current more than 22 volts, then here this fuse here has to then die in order for the ECU to save it. The OVP has two 87E contacts. One is the positive for the ECU, one is for the ABS computer, 87L, which is the positive for the OVP. That's in my case blue white wire, blue red, sorry, and red white is the negative, which comes from the ECU. It has contacts 30A. Those contacts are for the later models after 87, 89, where the ECU is always on. There is always the connection between the ECU and the OVP, and if anything goes wrong, then it has to report if there is an error or not and send it to X11/4. Concerning the OVP, when it malfunctions, it may come to some symptoms. For example, at the beginning it works, but after 2 minutes it does not work. If your car is warmed up and jumps into emergency mode, then most likely this is a problem, that the OVP is your problem. If the OVP is faulty, it may happen that it is going to fail to supply voltage to the ECU. It may not work right away, or it may not work after a while. So you will have to then start the engine, watch and see what is happening. Then look for a malfunction. If the OVP malfunctions or the fuse in it is blown, then a cool start will be very difficult. If there is frost, the engine will not start at all. If the engine is warmed up, the engine will go into emergency mode, and there will be an incorrect enrichment of the air-fuel mixture. And there will be an incorrect enrichment of the air-fuel mixture. But if the engine is warm, when driving it, you may not notice it, except at idle. Here, ignition on. Here, contact number 1. And watch now what happens as I connect the second part of the multimeter to the ground. Here, 12 volts. So again, contact number 1 on the ECU and ground. 12 volts, great. This means that both my ECU as well as my OVP work. And now the next segment of the video I'm going to dedicate to the sensors. So as I have already mentioned, the crankshaft position sensor is a very important sensor. Without that sensor, you cannot even start the car. And I'm going to demonstrate it to you now, that. And now, in real time, I'm going to demonstrate it to you. I'm going to plug out the sensor, and now I'm going to start the car. As you hear the tsak-tsak sound from the ICV, that is going to be ignition on. So let's hear in real time. The car now must not start. Now I'm going to connect the sensor. There. If goat lies, horn does not lie. Now, the next one is going to be the coolant temperature sensor. So let's measure the temperature of the engine. 23. So 20. Let's say it like that. 20, or for our Fahrenheit lovers, 75. Back to Celsius. Okay. So at 20 degrees C, as we can see here, we must obtain the value of 2 kilo ohm. Now I will remove the plug. I select resistance, and now one part for my sensor goes into the sensor itself, and the second part goes to the ground. Let's see. Two kilo ohm. And now the second one. Here. Okay. For the 4-pin sensor, you measure diagonally in a crisscross. And again, you repeat the measurement when the engine is warm. The point is, as the temperature rises, the resistance falls. And that's the point. If the coolant temperature sensor is faulty and out of the specs, it is simply being replaced. It cannot be repaired. The symptoms of faulty coolant temperature sensors are both cold as well as warm starts, poor engine dynamics, increased fuel consumption, and poor idling. We get everything back, and we go to our next sensor, and that is the sensor potentiometer. Here, in order to check the potentiometer, we remove its jack, and now we measure the resistance between the top and the bottom pin. Top pin ground, bottom pin and we get this value, 1.6 kilo ohm. Well, this is not the nominal value, but because this is not the OEM part, it's from Germany part, then it has different values. Otherwise, the values should be between 3.6 and 4.4 kilo ohms. And now I'm going to remove this bottom one and to put it in the middle. And this now is more important for the potentiometer, because now the value you get, you now start deflecting the sensor plate, and the resistance must start increasing smoothly without any jumps. Let's do it. I usually do not check this part. I replace it each 150,000 kilometers. We'll get this thing back. I was speaking about the sensor potentiometer. You can watch those videos here. If the potentiometer is faulty, the idle may fluctuate. The engine may go into emergency mode. So if the potentiometer stops arranging the electronic control unit in the idle mode, it will switch the idle speed to emergency mode. The air-fuel mixture may not be enriched properly. This happens because the tracks of the potentiometers are wiped out. And as they're wiped out, they're usually wiped out at half a way, at approximately, let's say it up to 3000 RPM. There where the engine spends the most time. For example, there the sliders are going to be scratching and scratching the potentiometer, and there it's going to be wiped out. Sometimes the idle is not wiped out, but that can happen also. For example, if the car has not been driven on a regular basis, and then the sliders can engrave in the position where the idle is supposed to be, and maybe not that much it's going to be engraved in the normal load at that position, but there maybe because the potentiometer is being replaced each 150,000 kilometers. And if the car has less than 150,000 kilometers, someone can say, aha, okay, I don't have to replace the potentiometer. But if the car has been sitting or the car has not been driven for a long time, those sliders can engrave and at the idle speed, and that's gonna make issue at the idle. And now let's see why we have floating RPM when the potentiometer is bad. Because on the place where the tracks are wiped out, the resistance is high or equal to infinity, and the voltage on these places is either too small or absent. Therefore, the ECU will perceive this as a small amount of air-fuel mixture, and it will try to increase the amount of air-to-fuel mixture by opening the bypass channel in the ICV more. The engine speed will increase immediately because there is no load on the engine. We have more airflow, and accordingly, fuel consumption is also higher. The pressure disc lowers and the potentiometer contacts lower with it, and suddenly at some point they find some kind of voltage that corresponds, for example, to a small load. For example, at 1000 RPM. The electronic unit sees this and tries to reduce the amount of air-fuel mixture. At this moment, it does not react to the readings of the TD signal at all. So the TD signal is this wire here, and it goes to the ECU, to the fuel pump relay, tachometer. It's an RPM signal. So then disturbances in engine appear. The channel closes and airflow decreases, and the amount of air-fuel mixture decreases as well. The contacts, together with the pressure disc, from this position rise. They rise and they fall into the sector, which is worn out, where again there is no voltage. And it comes to this floating RPM. There may be no RPM or warm-up speeds according to the potentiometer. The potentiometer may not bring them to warm-up speeds. And after starting, the warm-up speed may be minimal, for example 700 RPM. After that, it can come to emergency mode if the potentiometer is bad. This can be simulated by turning off the potentiometer, and the idle speed increases to 11 up to 1200 RPM. In the idle air regulators, they can be higher. The electronic control unit does not see signals from the potentiometer. Its signals stop satisfying him at idle. Therefore, the ECU turns off the idle control valve, thereby putting the system into emergency mode. In general, these are the main malfunctions associated with the potentiometer: incorrect enrichment of the mixture during acceleration. If the track is very worn, and when we start to accelerate, there will be no mixture enrichment. The next one in the row is the TPS, or the throttle position sensor. Here, next to the potentiometer, I will unplug its jack. Be right back. Here we see the 3 pins. This one is ground, the middle one. This one is full throttle, and this one is for the idle. So this one is very easy to check. I'll just dial my buzzer. So here this is the ground, and as I connect the other one to this contact, now we read infinity. Once I press fully the accelerator, the sensor must start beeping. Here, once again. And now, as for the idle, here the sensor must start beeping as soon as I connect. Here, and as I press the accelerator fully, it must stop. Here. So there. The sensor is good functioning. There is also a 2-pin TPS. That's for the older versions of the KE, and that sensor recognizes the full throttle only. That's the sensor you can find on the systems where you have the idle control valve with the 3 pins. Because the idle is still being adjusted manually, only the full throttle position or the wide open throttle is being recognized. You simply put the 2 leads for each contact, you press the accelerator lever all the way down to the max, and if it beeps, then the TPS is good. If the TPS is faulty, then the forced idle mode will not work properly. There may be an incorrect enrichment of the air-fuel mixture during acceleration and especially under full load. And also there are going to be increased RPM on idle at approximately 1200. The same way we're going to check the microswitch. So we remove its connector, and now we take our alligator leads. One of them we connect to the upper contact, and one of them we connect to the bottom contact. So not to the middle one, but to the bottom one. So we also there. As I just move a bit the accelerator lever, then the sensor must stop beeping. As I get it back, then it must start beeping again. There. So that one is good as well. Now, what happens if the micro switch does not work? The electronic control unit will not switch the system into idle phase. More precisely, it will regulate the idle speed, but it will not shut off the injectors at the moment of load shedding. That is closing the throttle valve. There will be poor engine braking and excessive fuel consumption. This will be especially noticeable on the highway. Also, the same will be the case with the throttle position sensor. And remember, one thing is important for you to know. Maybe sometimes the sensor as sensor is good, but sometimes the wiring harness that leads towards the sensors can be bad, and then you can have issues. So always when checking the sensors, you must check the wires as well. If you have continuity, then that's it. Everything's fine. So remember that. I'm going to demonstrate it to you on the example of the idle control valve. So I'm going to remove its plug, and now one part of the multimeter lead I'm going to stick in this one. This is a red-white wire, and this is the ground for it. There. And the second one I'm going to connect to the ECU plug. Let's disconnect it. It's going to be pin number 3, and it's this one. So we choose buzzer, and here, you see? So there, we have continuity, so the wiring is in order. And now, concerning the Lambda probe. Well, if you ask me how you check it, to tell you the truth, I never check that sensor. That's why I always ask you how many kilometers you made with your car, or miles. That's why I do. But if you really want to know how to check this sensor, you will have to then remove its plug. It can be either here somewhere on 190E or on the newer systems, on W124, it's down in the pipe, and the way you check it, you will have to unplug it. It's under the passenger floor mat. And then you must get fluctuation between 0.2 and 0.8 volts, as I remember, 200 and 800 millivolts, twice a second. Then you have a good functioning lambda. But as I told you already, don't bother yourselves checking it. Just replace it each 60,000 kilometers at most, and there you will have no problems with this sensor. Why? That's because this sensor cannot be repaired. It's simply being replaced. And that's why I don't even bother myself checking it. If, for example, my car made 140,000 kilometers, it was from the former owner, for example, and he never replaced the Lambda, I will replace it. And I don't even bother myself checking it. The symptoms of a bad Lambda probe, or the O2 sensor. The car behaves good while cold, but as soon as the Lambda reaches 350 degrees C operating temperature and the car 80 degrees Celsius, then we have poor idling, power loss in general, floating RPM, too rich mixture, and that's all because this sensor sends bad information to the ECU about the combustion in general. So whenever your car works fine while it is cold, and as it gets warm, you get floating RPM, you get power loss, the car starts stumbling. It's simply time for the Lambda to be replaced. And now concerning the speed sensor, this is its location here. It's behind the instrument cluster. So in order to replace it, you will have to remove the instrument cluster. In order to test this sensor, you need a helper. So what you will have to do, you will have to remove the EHA plug. And now, 1, 2, 3, 4, 5, 6. This is its location. You will have to stick the positive of your multimeter in contact number 6. This one here. And the negative goes to the ground, any part of your chassis. You will dial here DC volts, so you have to measure voltage, You turn the ignition on and you move the car for 1 meter. If with consumers you get 9 volts, it's okay. If you get 12 volts with consumers, then the sensor is good functioning. That's how it's being checked. The symptoms of a bad whole speed sensor is that, for example, the outside temperature gauge shows wrong readings, and you know that your probe is a good functioning one. Or if you have a cruise control, if the cruise control shuts off, for example, that can be one of the signs that your speed sensor is bad. Concerning this one, the air intake temperature sensor. This sensor now, as for the cars up to 89, September 89, I stress, mine is made in June 89, so it's the older version of the KE3, and now here I have this sensor connected to the contact number 11, and then that sensor sends signal both to the ECU as well as to the EZL here. And on the newer versions, the signal of this sensor goes only to the EZL. And in my last video, you've seen that I was speaking about the EHA. Commonly, to check the EHA, you will have to then at first check its contacts. One of them is connected to the contact number 12, this one, and one to the contact number 10, this one. In order to check the EHA if it is good functioning or not, at first you will have to take carb cleaner and to wash its filter here. It has a tiny filter. And you can just take a bottle of carb cleaner and flush it under pressure. And now, the most important thing for the EHA is to measure on these two contacts its resistance. The resistance should be 19.5 ohms plus minus 1.5 ohm. If that's okay, then you measure the current. If you get current and you get the differential pressure of 0.4 bar when the car is on idling, then everything is fine. In case you get the differential pressure as it is supposed to be, but you don't get the current, then check the voltage. If you have between 11 and 13 volts on it, if you don't, then check for continuity as well. Check the wires. Your wires are good. If the resistance on them is less than 1 ohm, you can check buzzer as well. That's how you check the EHA. If everything is as it is supposed to be, but you don't get the current, then it's this guy to be blamed and it's to be thrown away or to be repaired. Simply the resistors, as I believe inside, can be replaced and everything is going to be fine. Otherwise, if you get resistance on these two contacts outside of the specs over 19.5 ohms, then it's definitely the EHA, the problem. The symptoms of bad working EHA. The differential pressure is less than 0.4 bar. Commonly it's 0.2. So mixture extremely lean. The differential pressure almost non-existent. And if when you disassemble the EHA and you turn this screw, you don't manage to increase the differential pressure, then it's definitely the EHA. Extremely lean mixture, car that's extremely sluggish, no acceleration, poor power. What I'm talking about and what I was talking about in my previous video was that as you start the car, you get in 90% of all the cases 20 milliamps. As you start the car, the milliamps drop to 15, and then they start decreasing, and as the engine reaches the operating temperature, then the amps should fluctuate between -3 and 0, or +3, up to +3. It depends of that if you want your mixture to be leaner or richer. If you get, just in case, -10, for example, then what you will have to do, you will have to remove the EHA, to remove its protecting screw, and then you will have to turn the 2 mils Allen for, let's say, quarter of a turn counterclockwise. And if you get in positive range, +8 milliamps, then you will have to do the opposite thing. You will have to turn for a quarter of a turn clockwise. And again, you will have to mount it back here on the car and then you see how the sensor is behaving. So one more thing concerning the ECU. This is how you count your pins. Here, this is number 1, this is number 13, this is number 25. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Plus 12 down there, they make 25. And then you can check all your sensors. On this car specifically, let's check. Here, as you see, number 1 is the OVP relay 87E, number 2 ground, 3 ICV, 5 TPS wide open throttle, 6 whole speed sensor, and so on and so on. I'll put you the picture then afterwards. So when you have the connector like me unplugged, then you can check all your sensors. Just to make sure that you have all on each of them continuity, and there just to know. I don't show you now for all the sensors how it's done, because I know that my sensors are functioning. Concerning the cold start valve, I was showing you how I was checking it. So you will have to remove this plug, and then one contact, you can check it as well, goes to the fuel pump relay contact 87V, and the second one goes to the ground. So there you can check if you have interruptions or not. Then check the solenoid as well, and that's about the cold start valve. One more thing I will have to show you here. It's this thing. This is the so-called mass. It was mounted on the engines M103, 94 and something, and 981, for example, starting from the model year 1990, and on the M104 engines as well. So you have here 22 contacts. So they are practically identical for M103 engines that have this mass module. And concerning the ECU, and that ECU looks like this. It has 55 pins, as you can see here. There. Look how the connector is here illustrated, and the same thing goes for it. Here are its contacts. For example, here, let's say number 55 is the EHA ground, and for example 37 is the power supply, the positive, here, as you can see. It's different, it's not the same, it's different, and there you can check, you can beep all the contacts, Now let's say something about the idle control valve. Well, on KE3 and later systems, this valve has two pins, as you could see, and its nominal value as the car reaches operating temperature has to be between 4 and 6.5 volts. And concerning the models after September 89, it has to be 580 milliamps. And for the V8 engines, it has to be 1000 milliamps. So those are the nominal values for your idle control valve. What do we get? 12 volts. Great. So after driving a car to achieve the working temperature, now I'm gonna start the car and let's measure the voltage on the two pins on the idle control valve to see if we're in specs or not. So at the operating temperature, let's plug in the value 4.6 volts. That's it. Success. We're within specs. Yes. Haha, that's a happy Mercedes thing. There. Nothing but the truth. So, concerning the older versions, concerning this valve, you saw I've been doing the check. I've been showing you how it's being checked. You will have to just turn the ignition on, and if you hear that clock sound, then that means that the ICV is working, that the OVP is working, that your computer is working. And if you haven't, you can remove the valve itself and you can clean it with carb cleaner, and you can lubricate it with WD-40. Concerning the older versions, on the older versions you have 3 pins and you have one little wheel that goes here approximately under the EHA valve. So there you can, on that little gear, you can set your idle manually. And on this system, the idle is being controlled fully by the potentiometer. Concerning the 3-pin idle control valve, there is something I want to tell you about that valve. You need to remove the pipe, disconnect it, and with the ignition off, check for the presence of a hole in the bypass channel. If this is absent, the valve must be replaced. When you turn the ignition on, after you turn on the ignition, you look at the valve. What happens to it? The valve should open and close completely within 10 minutes. No more than 10 minutes. If this does not happen, the valve has to be replaced. You can try to wash it, because sometimes they get stuck. And now the symptoms of a bad idle control valve. It comes to difficult start, both hot or cold engine starts. There is a floating idle speed, and that's it. And sometimes the bypass channel is not adjusted correctly. So if something happens with your idle control valve, you wash it. Wash them with carb cleaner, then lubricate them with WD-40, and in the rule they should start functioning again. Their coils rarely overheat. If their coil is burnt out, then you will have to replace the idle control valve. If the valve does not work for some reason, you need to check the voltage on it and to open up. If the valve does not open, you need to check the power to it, whether it comes or not. For this, you turn the ignition on and connect the wires. You connect the tester to these connectors. You have the middle contact. It's a common power supply, and two contacts that regulate the position. They go to the ECU and adjust the position of the bypass channel. Check the voltage. At different temperatures, this voltage should be different. So what's characteristic for the 3-pin connector? At the start, their voltages increase and they go up to 8.5 volts, and as for 2-pin idle control valves, their voltages decrease. That's one of the difference more. Considering this system, one more of the sensors is the altitude sensor, and unfortunately I don't have a car like that and I cannot show you how it looks like, but I was speaking about that. I will leave you the link here, and you can inform yourselves how the sensor is being checked. It's also being replaced. You cannot repair it, unfortunately. So, if you liked this video,
please consider subscribing to our YouTube channel and click the bell to be notified when we post new videos.
Then I would kindly ask you not to hit the button skip ad. That is going to help me a lot. And till some next one, happy Mercedesing. Bye.